amount of less than 2.7. You can see our learning goal has changed a little bit today. It says I can solve special cases of absolute value inequalities. Still working with absolute value. Absolute value says what? What one word should you think of when you hear the words absolute value? Distance. That should automatically come to mind. Absolute value, oh, that's talking about distance. Distance from where?
0.
From 0, right. Okay, so we're going to still be solving absolute value, and we're going to still be solving inequalities. So, special cases of absolute value inequalities. When the absolute value expression is supposed to be less than 0, let's circle that, is supposed to be less than 0. When the absolute value expression, so in other words, the absolute value expression is already by itself on one side, and when it's supposed to be less than a number that is less than 0, what kind of numbers are less than 0? Negative numbers. We're going to say there's no solution to those kind. So here's an example. The absolute value of x is less than negative 1. Is negative 1 less than 0? Yeah, okay. So it's less than 0, it's negative 1. So this says that x must have a distance of less than negative 1, right? That's what it's saying. X has to have a distance. Its distance has to be less than negative 1. Can it?
Yes.
How? Is there such a thing as negative distance? We don't talk about distance being negative, so we can't have, this is the clue right here, distance of less than negative 1. So we're talking about it being, because the only numbers less than negative 1 on the number line are negative, so we're talking about it having to have negative distance. So we're going to say no, and we're going to put because distance is positive. We always talk about distance as being a positive number. We don't back down the street and say we went a negative distance. We don't say if you're going south of town, you go a negative distance. If you go north, you go a positive distance. Cody?
So isn't it if you like, say you go 5 miles this way and you go 10 miles that way, technically you just went 5 miles from where you started.
Okay.
So.
But how many miles did you technically really cover? How much distance did you really cover, Cody?
15.
15 miles. Mm-hmm. So the distance is still 15 miles, and we don't talk about it being negative. But you're talking when you're talking about negative, there you're talking about direction more than you are distance. Okay. So therefore, the absolute value of x is less than negative 1 has no solution. So once the absolute value expression is by itself, it says it has to be less than 0. Well, negative 1 is less than 0. Or in other words, it has to be a negative distance. We say, you know what, can't have that. We say no solution. So let's see some examples of that happening. Number 1, the absolute value of x plus 2 is less than or equal to negative 2. First thing we always ask ourselves is what? What's the first question, no matter what kind of absolute value inequality we're solving? Tori, what's the first question you have to ask yourself every time? Want to pass? Or do you want to pay attention? Okay. Cody?
Is there anything multiplying, dividing, or adding, or subtracting to the absolute value?
Yeah. So the absolute value expression can't have anything happening with it. It has to be by itself. That's the first thing we have to look for. Is the absolute value expression, well, I don't care what's inside of it. Is there anything happening outside those bars that mean absolute value? So is there a number 1? No. Okay, so now we can go right to getting ready to solve it. We have to decide, you know, it says is less than or equal to, well, is less than or equal to, a couple of days ago, Matt, you set up a compound and inequality, didn't it? It had to be somewhere between two numbers. This says the distance has to be less than negative 2. So let's see. Let's write that down. Distance has to be less than or equal to, I guess it says, it does have the equal to bar. So that's saying the distance of that x plus 2 has to be less than or equal to negative 2. In other words, it has to have a negative 2 distance or something smaller than negative 2. Can it? No. So, no negative distance. So we're going to say no solution. And you're going to justify it like this, okay? Because we don't have to do any graphing today. We don't have, lots of times we're not going to do a whole lot of solving, so we're just going to have to make decisions based on what we see there. So we're going to write down something like we just did here. Distance has to be less than or equal to negative 2. There isn't such a thing as negative distance, so we're going to say no solution. Okay? How about number 2? First question you're going to ask yourself, Noah, is what?
If the one is if there's a positive and negative on the right side.
Well, that's not going to be our first question. We eventually are going to be worried about that. Abby? Do you have to do some getting rid of some subtraction or addition or multiplication or division to get the absolute value expression by itself? Do we? Do we have to do anything to get the absolute value expression by itself? Yeah, what do we have to do, Abby? Yeah, we have to subtract 5. We don't have that by itself yet. So we don't make any decisions about how to solve this until we do that. So now we have the absolute value of x take away 1 is less than what? 1 take away 5. Negative 4, yeah, it's like 1 above 0, and then it drops 5 degrees. It ends up at 4 below. Okay. What's this say? What are we going to write? What does this say? Distance has to be what? What does this say? Distance, absolute value of ours mean distance. Distance has to be
Distance has to be
less than negative 4. Okay, so that's our saying, okay, here's what's happening here. Distance has to be less than negative 4. Can it be?
no.
No. So let's be lazy. Let's write can't be. So what's our solution?
No solution.
No solution. So tell me, do you think I'm gonna let you get away with going from you do it to this point right here, you're done with this point, and then you jump down and you do this? Think that's I'm gonna allow that?
No.
No. We're doing that other stuff in between because we are eventually going to see all types of absolute value inequalities all mixed together, and our brain has to process what kind is this. And they're not all going to be special cases. Today we're practicing special cases 1, but they're not all going to be from here on out. We're going to have to process each one of them alone. Okay. Kelvin, what do you think about number 3? What do you think should be your first thought?
Well, that's negative.
Okay,
You can already see it's no solution.
you can already see it's no solution. Nice.
But you have to show words.
You're so smart. That is so right. Thank you. What kind of work do you want to show? Help me out. Because I want to know what you're going to show me on your paper for tomorrow.
distance has to be more than, not less than negative.
Are we ready to talk about distance yet? What are we gonna do first, Devontae?
Divide by 2 on both sides.
Because why?
Get rid of everything outside of the those bars.
Yeah, what are those kind of bars called? Absolute value bars?
Oh, yeah, absolutely. Yeah.
We're gonna get rid of those, everything outside those absolute value bars. So the first thing we have to do is we have to divide both sides by 2. That's our first move. And then we're gonna say, oh, now the absolute value expression is by itself. And what's negative 4 divided by 2?
2, negative 2.
Negative 2. Should we switch the sign?
No,
Why not?
you didn't divide by negative.
We didn't divide by a negative. We divided into a negative, but that doesn't matter. We didn't divide by. So now the absolute value expression is by itself. Now, as Calvin said, it's quite clear that there's a negative number over on the other side, but could it have changed?
Yes.
It could have.
Because if you had subtract 3 instead of plus 3, you could be a positive 1 instead. Right?
With that negative 4, you mean?
Right here.
Oh, well, no, because that's inside the absolute value box, so we don't really care what's going on
When
inside.
you finish the equation and you get x plus or minus 3 is less than or equal to negative 2, if you added 3, you get positive 1 instead.
Okay, but what you're trying to do, Cody, is you're trying to take it and set it up as if we could solve it already. We're at the point where we have to ask ourselves, can we solve this? Should we set up an and compound inequality? Should we set up an or compound inequality, or is this a special case?
Special case.
It's a special case. And when it's a special case, we're going to say, oh, this says that distance must be what? What is this telling us?
Must be less than or equal to negative 2.
Less than or equal to negative 2. That's what this is saying. Can it be?
No.
Do we have any positive distance?
No.
Starting at negative 2 and heading left? No. So we were going to say can't be. No solution. So notice, just because there's a negative number over on that other side in the beginning does not mean that it was ready for us to say that, because that 2 was not part of the distance. So we have to talk about, we have to get that 2 out of there first. And then we can talk about what kind of distance do we need here, and what kind of way should I go about solving it. Okay. How about number 4? What do you think we should do? Julia? What do you want us to do? What was it? Add 2 to both sides, okay. Why are we adding 2 to both sides? Yes. The absolute value expression is not by itself. We got to get that 2 out of there. So now we have the absolute value of 6x is less than what?
0.
0. Okay. Think about that. What does that say? What's that tell us? What's that saying right now? Has to be less than 0. What has to be less than 0? The distance has to be less than 0. Not x, it's saying distance has to be less than 0. How do we feel about that?
Distance must
Are
be
there any
less.
numbers less than 0 that are positive?
No.
No. So let's write that down. Distance must be less than 0. And we're going to say, you know what? Can't be. That means it have to be negative. And we can't have negative distance, so we're going to say no solution. Okay. Now, I know that when we practiced all these on the front, they all came out as no solution. I'm just showing you different types of things you might have to do before you can make the decision. In your homework, they're going to be mixed up, these special cases, okay? So don't, it'd be like, oh, there's a group of problems 14 through 19 to do. Those must be the no solution ones, and the 33 through 38, those must be what we're going to do on the back side. No, they're scrambled, okay? So you're gonna have to make a decision based on what actually ends up happening. So anybody have questions about the no solution ones? Anything still not clear? Or what you need to show? Okay, then I'm gonna trust you're gonna do it. Let's go to the back side. Here's our other special case. When the absolute value expression is supposed to be greater than a negative number, the solution is all real numbers. Now notice it didn't say, in fact, let's circle that again. Supposed to be greater than a negative number. Notice it didn't say 0 this time. It says supposed to be greater than a negative number. What's true about distance again? Distance can be what? It's positive. Can it be 0? Can there be 0 distance?
Yes.
Yeah, stand still, don't go anywhere, that's 0 distance. So the distance can be 0. Distance can be positive. It just can't be negative. Well, so basically we're saying if it has to be greater than a negative number, is 0 greater than a negative number on the number line? Any negative number you talk about is 0 greater than it?
Yes.
Yeah. Are all the positive numbers greater than any negative number on the number line?
Yes.
So basically we're saying, you know what? If distance just has to be greater than a negative number, there's all those possibilities. So it can be, so what we're going to say here, all distance is greater than a negative number because all positive numbers and 0, we're going to put, let's add that in here, I should have that there. Because all positive numbers and 0, what distance can be positive, distance can be 0, are greater than all negative numbers, so I don't care what the negative number is over there. All distance is greater than any negative number you choose. Because distance is positive, all the positive numbers are greater than negatives. Distance can be 0, 0 is greater than all the negatives. So the absolute value of x is greater than or equal to -4 is really telling us, is really saying to us that a positive is greater than -4. Positive, or we could put this 0 in here again, or 0 is greater than -4. Let's play around with this one a little bit and see if that helps. Pick a number from the number line for me. Noah, what number do you want to pick? I don't care what it is. 21. Okay, we're going to put it in here. What's the absolute value of 21? What's the absolute value of 21? 21 is greater than -4. Is 21 greater than -4? Absolutely. Okay. Aurora, pick a number for me. 5. Okay. The absolute value of 5. What is the absolute value of 5? 5. This should be, how far is 5 from 0 on the number line? It's 5 units away from 0. Is 5 greater than -4?
Yes.
Yes. Somebody pick a number other than a positive number. Cody?
1/2.
Is that a positive
Negative
number?
1/2.
Negative 1/2. Okay, let's do -1/2. What's the absolute value of -1/2?
1/2.
1/2, thank you. Is 1/2 greater than -4?
Yes.
Okay. Somebody pick a number smaller than -4.
-13.
Negative, what was that, Devante?
18.
-18. Okay, what's the absolute value of -18? 18. Is 18 greater than -4? Are you starting to see that it would not matter what number we chose to put in there for x, whether it's negative or positive? Oh, let's try 0. What's the absolute value of 0?
0.
Is 0 greater than -4?
Yes.
Yeah. No matter what number you would choose from the number line, it would make that inequality true. So that's why we can say that the solution is going to be all real numbers. Okay, let's try solving number 5 here. What are we going to do first? Okay, Tori, I'm going to give you another chance. What do we have to do? What's our first thought always?
Subtract 7.
Okay, because we want to do what? What's the reason we're going to subtract 7? I so agree with you, and I think a lot of people in here will, but what's the reason for doing that? Forgot. Abby? Gotta get the absolute value expression by itself. Tori, did you hear that? Gotta get the absolute value expression by itself. That's the reason we do it. We don't just do it because that's what we've been practicing in class. What's the reason we do it? Okay, and now we have the absolute value expression by itself is greater than what? -5. So this says distance must be greater than -5. So how do you feel? Distance has to be greater than -5. Distance again is measured in what? How many? What kind of units? Either positive or 0. Is 0 greater than -5? Is every positive number on the number line greater than -5?
Yes.
Yeah, it is. So we're going to say that all real numbers, I'm going to let you just go right to writing this, all real numbers is your solution. Because all distance is greater than -5. Okay. Go ahead and do number 6 on your own. What'd you do for a first move? Devontae, what'd you do for a first move?
Add 9.
Added 9, okay. Which left you with what?
X is
Absolute value of x?
oh your absolute value of x is greater than or equal to 2.
2? Julia wants -2. What do the rest of you want?
Negative.
-2, yeah. We didn't add enough to get out of negative territory, did we? Okay. So what does this say before we make a decision here? What does it say? Right?
Distance must be greater than
Okay. So how do you feel about that? Do you think distance can be greater than -2? Yeah? Okay. So distance must be, and we're not going to worry about the equal to part because you know what? Can it be equal to a -2? Yeah, it only has to be one or the other, right? Or greater than or equal to. So distance must be greater than -2. We don't have to even worry about the or equal to because it can't be equal to -2. So we'll ditch that one right away. But can it be greater than -2? Yeah, all distance is greater than -2, isn't it? 0 is greater than -2. All positive numbers are greater than -2. So this is all real numbers. What if it would have said absolute value of x is less than or equal to -2? Then it would have been distance has to be less than or equal to -2. Well, it can be equal to -2, so we'll ditch that. Can it be less than -2 distance? No. Then it would have been, this would have been a no solution one. So you're going to have to make the call based on what it says when you write out what it's telling you. Okay? Okay. Number 7. Well, who haven't I picked on here yet at all? Anybody? Oh, you've offered up answers. No, it must be time to call on you again. What should we do?
Divide by 2 on both sides.
Do what?
Divide by 2 on both sides.
Okay, divide both sides by 2. Okay. And what's our reason for doing that, Noah?
To get the absolute value of ours along with the answer.
Okay, so get the absolute value expression by itself. Okay. Did we divide by a negative? Nope, so we don't need to switch the sign. -4 divided by 2? -2. This says what? Cody, what's this say?
That says, the absolute value is greater than or equal to -2.
Okay, but we say absolute value is what?
Is
What's that
X.
one word? No, what's that one word that replaces absolute value? Did you hear back there? Distance
Distance.
must be greater than -2. Remember, it can't be -2, so we're not going to worry about the equal to part. It just has to be one or the other. So we're going to go with the, can it be greater than -2, our distance?
It says equal to.
It does, but we're going to ditch, we're not going to put that in our explanation because we already know distance can't be -2. Right? So we're going to ditch that and say, okay, well, let's see if it satisfies the other one. Does it satisfy the is greater than -2? Distance must be greater than -2. How do you feel about that? Can it be? Will it
Yes.
always be?
No. It won't always be greater.
Yeah, it will.
Greater.
Because distance will either be what?
Greater than or equal.
Positive or 0. Are positive numbers greater, are all the positive numbers greater than -2?
Yep.
Is 0 greater than -2?
Yes.
Yeah, so this is all real numbers.
Plus
Okay. And number 8. First movement number 8, Aurora. Okay, add 3 to both sides. Got to get that absolute value expression by itself. X plus 2 is greater than
2.
2. Okay, what are we going to do? Cody, what are we going to do?
We
Apparently
are.
yours is already done because you got other things you're doing there. Okay. What are we going to do? Is there a negative number over on that other side now? Huh, is this a special case then? If after the absolute value expression is by itself and there's a negative number on the other side, then it's a special case. Now, why did I throw this one in here? Because here's what you might have done. You might have looked at this one and said, oh, there's a negative on the other side. This is a special case. But can you make that decision at the beginning? Always? No, you have to make sure the absolute value expression is by itself first. So let's finish this one because we know how. This says the distance of x plus 2 has to be more than 2 units away from 0. Can we have 2 units of distance? Can we have more than 2 units of distance? Yeah, so more, it has to be more than 2 units of distance. It can't be 2, there's no equal to bar there, right? So it has to be 2 units of distance away. What numbers are more than 2 units away from 0?
4
and
3 and blah, 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 and are there any other numbers on the number line that are more than, other than these guys over here? Past 2? How about what negatives? Past what?
-2.
Past -2, so like -3, -4, and all those. Oh, this is what kind? What is this?
All
Starts
the
here, goes
numbers.
that way, starts here at -2, doesn't include -2s, goes that way. Starts here at +2, doesn't include it, but it goes that way. This is an OR one, isn't it?
Yes.
X is less than -2. Those are all the numbers that have a distance of more than 2 units going that direction. Or
X is greater than 2.
X is greater than 2. Have we got the solution or do we have another step to do? Is X by itself? Yeah, so this is our solution for this one. And this one we have to graph because we actually got a solution. Other than all real numbers or no solution. So, I don't know if this happens in your homework, but be aware just in case. In other words, the point being, You can't just look on that other side and say, oh, there's a negative over there, so this is a special case. It's only a special case when there's a negative on the other side and what is on the opposite side. That's true. What has to hold true on the other side? Absolute value expression has to be by itself. Okay. Any questions? Again, they're going to be scrambled in your homework, but they should be special cases. I don't think any trick ones are thrown in like I did in the notes. I threw the trick one into the notes so we'd be ready for tomorrow. And we have to combine all 3 days worth into a good assignment. Okay, you can get to work on your homework.